students?
Hello.
You know, we are still on measurements and units. We're still on measurements and units. We have explained what unit means. We have done quantity, fundamental quantity. That is what we measure the quantity, the fundamental quantity, and derived quantity. We are through with dimensions of those quantities. Now today we want to go into measurement proper. Now anything that you can measure is a quantity. So we can measure length. So length is one of the quantities we measure in physics. So at your level, the instrument we use in measuring the length and their scales is what I'll explain now. Now, length. One of the instruments we use in measuring length is meter rule. This is a meter rule. As you can see, it's calibrated in cm. From here to here, if you check the end, is in cm. So, now how do we use meter rule? If you want to use meter rule, you look direct through these calibrations. You look direct through the calibrations. If you are, for instance, this is a meter rule. If you measure from here, if you look through these places, an error due to parallax is incorrect. If you want to really get the accurate length of anything you're measuring with meter rule, you look direct through this calibration. Direct through the calibration, where you are assuming we are not the length is at 3. So you look direct through this calibration and you get your correct answer. Any other direction you look through is incorrect, and we call it error due to parallax. We call it what? Error due to parallax. In fact, anything with calibration, if you don't look through anything in calibration form, any measuring instrument in calibration form, if you do not look through the calibration on the instrument, or you look through one side or the other, you definitely get a wrong answer due to parallax error. Okay. Now another instrument here is the calipers. Is what? The calipers. Now, there's this instrument. Sorry, we don't have the instrument here. But I want to show you the instrument, the picture of the instrument. I want to show you the picture of the instrument. You can see, as you can see it. This thing is a caliper. This thing is a caliper. Okay, this red one is a caliper. This is a wood. Assuming you want to use the caliper to measure this, my marker, you will first of all, is in this form. You will use it to hold the marker tight, okay, and then you take it, you just remove the marker and you go and you place it on the meter rule 0, assuming this is a caliper now. The breadth of this meter rule is 4 cm. Of this my marker is 4 cm. That is what they did here. They use it to clip on the two sides of the cylindrical pipe. If you want to measure the you use to clip the two sides and then remove it and take it direct to this point here at 5 cm and 3 cm. Now the distance from 3 to 5, from 3 to 1 to 4 is 1 cm, and to 5 is 2 cm. So what is the dimension of this, the width of this cylindrical pipe is 2 cm. Okay?
Yes, ma'am.
So there is no way you can use straight meter rule to measure the wide of this something in this form. That is why they use this, and they call this one calipers. The what? Caliper. Another one, that is what I did here. You use the caliper to click on the two sides of this cylindrical pipe, and then take it just like that and place it on meter rule. You now calculate from the point that the first one hand is to the point that the second one hand is. 1, 2 is 1 cm, then to 3 is 2 cm. So the length of this my cylindrical pipe here is what? 2 cm. That is the length. Okay? Why the length of whatever I measure with meter rule is what? Exactly at 3 is 3 cm. Okay? Yes, now another instrument you use in measuring length is vernier caliper. What? Vernier caliper. Now this vernier caliper, you can see the picture here. The vernier caliper has two jaws. I'm very sorry, we are not able to get all these things, but during practical, some measurements in practical physics, I will show you. So this is a vernier caliper, picture of a vernier caliper. Now it has two jaws, this one and this one. If you want to measure inside internal dimension of cylinder, you use this side, this upper jaw. If you want to measure the external dimension of spherical objects or cylinder, you use this outer external dimension. Now see, this green part is a movable part. Is clink on just something like a meter rule. It's in iron form. Two of them are iron form. So you can push this in, adjust it forward, you can push it backward, depending on the size of the things you are measuring. Now you want to use this to measure. You adjust this green part until you hold that object firm. If you hold the object firm, okay, then you are going to read on the inside one, which is like a meter rule. You take reading, and we call this the readings on this one, this straight yellow one, we call it main scale, and we call the reading on this moving one, which is the green one, we call it vernier scale. Then how do you do take the measurement? How you take the measurement? You start from here to calibrate. This is 0 to count. From here to here is 0. So another longer calibration. This small calibration is points. Like this is 0.2, 0.3, 0.4, 0.5. Then to 1. This is 1. This long one is 1. Each small calibration is 0.2. So this one is 1, and the next longer one, you count it here is 0. You have another longer one, 1. You have another longer one, 2. And you have another small one. They are the 0.1. So these two, this calibration is in millimeter, and you can still convert it to centimeter. Okay? So if you are calculating this, you call this in tens. So this is 1, that is from here 10, 20. You now count that small one, 21, 22. Then you now check where the calibration on the yellow one coincides with the calibration on the green one. And when you note it, you will now count your numbers on the green one from the end to where they coincide. Okay, let's go debug. Now, this is a vernier caliper that I cut off. This is the green one, this is the yellow one. Now, I want to read this vernier caliper. Assuming I use this vernier caliper to measure something and I cut it, and I want to read. From here, this calibration is in millimeter. This thing is 9 division. The calibrations is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this vena scale scale is in 9 division. Now I'll count from here to here is 10, 20. Okay, this is 20. Where it ended is 20. Before where I crossed the vena caliper, the vena, I adjusted. Maybe I hold the object here, and this is where the green stopped. So immediately after 20. Okay, so my main scale here is 20 plus 20 millimeter. Okay, plus vena scale. Where did it coincide? See where it coincide. This here, where this line join with this line. That is what I mean by coinciding. See where it join. You have a straight line. If you check other line, it will just miss it slightly. But if you come, it did not miss this one. It just straight. Okay, so this place that I missed, that is where I will stop. Then I'll start counting from here. 1, 2, 3, 4, 5, 6. Are you seeing it? So in my main scale, main scale is 20, while my vena scale is 6 millimeter. I have to add up. If I want it to be in millimeter, it will be 20. Permit me to write here because of space. It will be 20 plus 6 millimeter. So what will it be now? Here to here is main scale. This is 20. Alright, I'm measuring in millimeter. This is 20 millimeter. Then this one is 0.1, 0.1, 0.2, 0.3, 0.3, 4, 0.5, 0.6. So my reading here is 20 plus what? 0.6. Are you getting it? Yes. My reading is 20 plus 0.6. So you can now use your calculator there. 20 plus 0.6 is what? 20.6. 20.6. So the reading of my measurement here on this vena caliper is 20.6 millimeter. Okay. Now to change it to centimeter. It's just 10 centimeter make 10 millimeter make 1 centimeter. So it will be 2 points, which is still equal to 2.06 centimeter. So that is how to read it. Hope is easy. Yes, so you can read anywhere you see the question. You see a question like this in exam, you just check where the line, this where it stop, that is your main scale, before the line that is the vena this thing scale. Then take the number and count these ones in 10, that is in millimeter, and you check where the number here, the calibration here coincide with the calibration here, and you count from here. That is your answer. Okay, that is how to read a vena caliper. Now another instrument is micrometer screw gauge. What? Micrometer screw gauge. Now micrometer screw gauge, this is the picture of a micrometer screw gauge. This is a picture of micrometer screw gauge. Have something in this form. It has something in this form, and that is this one, calibrated round. So when you want to, this place is open, that is its space where the object, this is where you put the object, this is the space. Okay, so you use this in this space to hold the object. You put the object between these two rod, and you screw it just this way. You screw it this way. You'll be screwing this one this way. You'll be doing it this way until the object is tight. Just assuming I kept something in between, and I'm tightening it like this until the object is tight. Then when it's tight, you will now check this micrometer screw gauge is calibrated this way, and this thing you are using to screw is also calibrated. Okay, so the first thing you do, the calibration along this part is the main scale, while the vernier scale is on this part. Okay, this one you're using to screw. So you now check from here to here. Okay, this is the value from here to here. You know where you're screwing is some part will be entering inside. Okay, so where you stop from here, you now calculate the distance between now here and here. Okay, where this plastic stopped. Then you will now check the calibration that's straight. You know there is a straight line like this. If I calibrate, so the calibration that is straight coinciding with that straight line joining that calibration on this particular one, where they coincide, that is your vernier scale. Now I take you to this place. This is this is a vernier caliper, right? Let's go to the board. This is the one that I screwed to tight up the straight calibration. This is the long part that join where the object is holding. Okay, now I want to take my reading. This is 0, this is 5. Okay, this is 0, this is what? 5. Okay, see where this one coincide. After this 5, see where it coincide. This is 25, where that straight line joining these two calibration coincide with that calibration around that round something is at what? 25. Is at 25. Assuming I cut, as I was saying, I cut this one, and this is the round one that I screwed, just like my marker that I was screwing the cover, and this line join that straight line is 25, right? Now this is my main scale. I want to read. This is 0, this is 1, 2, 3, 4, 5, 6, 7. But you see, it's in between 7. The round one is in between 7 and 8. So it is now 7.5. It's what? 7.5. My main scale is equal to 7.5. Okay, now that is my main scale. Then I now go to vernier scale. This is the vernier scale. Where did it coincide with this straight line this way? Where did it coincide? 25. It's 25. So it's not 25 because it's millimeter. It's 0.25. Okay, so my vernier scale is equal to 0.25. Okay, and how to get the total reading is always main scale plus vernier scale. Okay, so you have 7.5 plus 0.25. Okay, 7.5 plus 0.25 is what? Is 7.75. Okay, so the reading here is 7.75. all right, that is how to make use of the vernier scale, micrometer screw gauge, vernier caliper, the caliper, meter rule to measure length. Okay, now I want us to take an example from WAEC question. You know, I told you from the beginning that each question we'll solve, we'll try if we can face WAEC, the WAEC if it comes. Now, WAEC question 1988, question number 4. WAEC question objective 1988, question number 4. This is the diagram. WAEC question 1988, question number 4. Now, this is the diagram. The diagram, see it. You see the yellow one, you see the green one attached to it. Just the way I drew it on the board. And the question said, the diagram above represents a portion of a vernier caliper, which is in what is the reading? Okay, now we take the reading. this is where it stop. We have our 6, right?
Yes, ma'am.
6 1, 6 2, 6 3 before that line that joined to it, which is the green one. So we have our 6 3. So our main scale is 6 3. Now where did it coincide with the green coincide with the yellow here? You start searching. It coincide, you count from here, it coincide here. This is where it coincide. That you have your straight line. This is where it coincide. Two of the line join. You can see it very well. There is no shift, just a straight line like that. Okay, you start counting. 1 2 3 3 4 5 6 7 8 7 8. Do you see it?
Yes, ma'am.
7 8. Yes, it coincide at 9. 7 8 9. Okay?
Yes, ma'am.
So did you see it now? You add. You do what?
Add.
You add. We have 9. Okay? We have 9 and we have 6 1 2 3. Okay? So you get your answer. You add the two answer. So the vena scale from what we saw there is the main scale from what we saw there is 63 millimeter. Then the vena scale is 0.9 millimeter. So the total scale is 63 millimeter plus 0.9. Please, in you know we are using compiled question and answer. There are a lot of typographic errors, so I will not be working with what I assume to be the answer, but what I see here because it's measurement. So from what we see here, the way it coincides and all, this is our value that we got there. So 63 millimeter plus 0.9 is what? 63.9 then millimeter, and it's the same thing as we want to change it to centimeter. Is now 6.39 centimeter. Okay, that is the from what we see here in the diagram. Okay, so if you have the real wire question paper, it might not be exactly where is we find it there, but just follow the way we did our own, then you'll be able to read it. You can try every other questions on this particular topic: measurement of length, micrometer screw gauge, and using micrometer screw gauge, vena caliper, and meter rule. You will see it in different objective questions in past questions. Then try it. If you are finding it difficult, you can always contact us on our comment page. You ask question or our WhatsApp